Hi everyone. So first of all, I would like to thank you for accepting my presentation to present my work today in front of you. So my work is entitled Fertilizing Power Evaluation of Different Mixtures of Organic Waste Compost. We're going to start with an introduction, materials and method, results and discussion, and at the end, we're going to finish with the conclusion. Morocco is one of the major olive producing countries with an annual production of 1,414,000 tons. For the national production of olive oil is estimated at 142,000 tons per year, on average between 2015 and 2019. In recent decades, this increase in production and the introduction of the modern oil extraction technologies have placed the olive tree in a delicate position as a potential polluter. The environmental problem of olive pomace remains unresolved. The olive growing countries, particularly in the countries on the southern coast of the Mediterranean, such as Morocco, which have begun to modernize the industrial sector through vast programs with the aim of increasing and improve the quality of olive production. It's therefore necessary to find effective and feasible solutions in these developing olive countries. For the materials and method used for this work, the olive pomace used in this study were collected from a crushing unit with a traditional system located in Tiflis city. It's the city in the province of Homs in the Rabasali Kenitra region. For the organic household waste was generated from the wholesale market in the city of Salih. A mixture from these two materials was prepared. A catch of about 5 kilograms of each sample was well mixed and homogenized and then put into barrels. The latter were supplied with air and turned periodically to ensure a good aeration in order to promote aerobic fermentation, and the humidity was monitored and adjusted. The compost stability and maturity are achieved after almost 120 days. For the physical and chemical characterization, in order to characterize the mixtures, raw materials, and compost, from a physicochemical perspective, a representative sample is dried in an oven in a temperature between 40 degrees Celsius and 60 degrees Celsius, ground and sized to 2 millimeters to determine the pH and the electrical conductivity, and to 0.2 millimeter to determine the other mineral elements. For the moisture content is determined by drying the sample at 105 degrees Celsius until a constant mass is obtained. For the organic matter and the total organic carbon were characterized by initial loss at 525 degrees Celsius for 4 hours. And for the total nitrogen was measured by the Ghizlane method. For the biological characterization, the of the different samples was carried out at the beginning and at the end of the composting process for fecal pollution indicator. Fecal coliforms were counted by the 3 NPP method. For the raw materials characteristics, the olive pomace and the organic household waste were characterized by an acid pH and a high organic matter percentages and a high carbon nitrogen ratio. The pH is an essential factor which entering the majority of the reactions, which allows the availability of the nutrient and the solubility of the mineral elements for the microorganisms. After composting, the pH underwent an increase tending towards neutrality from 6.01 to 7.79 in the mixture, The electrical conductivity shows the compost salinity degree and indicates the effectiveness in feed toxicity tests and when used as a fertilizer for plant growth. The electrical conductivity underwent a decrease tending from 3.40 millisiemens per centimeter to 1.80 millisiemens per centimeter in the mixture. Humidity is a very important parameter for a greater microbial activity, which accelerates the composting process. The mixture underwent a decrease tending with form from 62.13% to 18.22% in the mixture. The organic matter content diminution is ensured by different groups of microorganisms that work according to the temperature, evolution, and the compost mass. Furthermore, bacteria leads the composting phase early, while fungi are present throughout the process, but are very active at water levels below 35% and inactive at temperatures above 60%, 60 degrees Celsius. As well as fungi, actinomycetes predominate during the maturation phase, which have the ability to degrade very resistant polymer. The organic matter underwent a decrease tending from 93.93% to 45.79% in the mixture. In this study, we observe a decrease in the carbon-nitrogen ratio for all the mixtures due to the mineralization of the organic matter, with a strong decrease in the mixture whose carbon-nitrogen ratio went from 31.75 at the stage initial to 18.56 in the final state. The pathogenic microorganism presence is composted waste. Composted waste can represent a potential risk of contamination of harvested plants where compost has been spread. The use of composts in the agricultural sector requires the validation of their agronomic efficiency, but above all the assurance of their environmental health safety. The mixture's studied characteristics show a high concentration of fecal coliforms at the beginning of the composting process, and which suffered a reduction at the end of the treatment, with a strong reduction in the mixture from 4.54 at power 10 of 7 coliforms per gram of dry matter to 4.50 at power of 10 for 3 coliforms per gram of dry matter. To conclude, the composts produced in this study were satisfactory for their agricultural application, with a natural pH in all the mixtures, an optimal carbon-nitrogen ratio around 20, the electrical conductivity that does not exceed the limit value of acceptance for use as a support for the ground, which is 3 millisiemens per centimeter. In addition, the mixture suffered a decrease in terms of pollution indicators. These composts contain nutrients that can allow them to play the role of fertilizer and supports for soil poor in minerals. And thank you.